What if I told you one formula connects the 5 most important numbers in mathematics, and does so with some kind of poetic precision that borders on the divine? This isn't numerology, this is Euler. This is mathematics in its most perfect form. So let's meet the players in this miraculous identity. We have E, the base of logarithms. It appears in growth, calculus, and chaos. The imaginary unit I, which is defined as the square root of -1. It's a number that challenges what a number actually is. You got pi, the circle constant, which naturally it's going to show up pretty much anywhere. You have 1, the identity for multiplication and division. And you got 0, the void, the silence between notes, the nothing that gives meaning to everything. And somehow all of them come together in perfect harmony. Picture it, Switzerland during the 1700s. Leonhard Euler, perhaps the most prolific mathematician in history, published so much math that even centuries later, we're still unpacking them. In the mid-18th century, he asked a bold question. What happens when you raise a number to an imaginary power? And what does that even mean? So he did what Euler did best, he turned to power series. Imagine the Maclaurin series for e to the x. Now replace the x with ix and something magical happens. The series splits into real and imaginary parts, and you'll notice that the real part is a Maclaurin series for cosine, and the imaginary part is a Maclaurin series for sine. And this gives us Euler's formula. Euler wasn't just solving a problem, he was revealing a deep structure within math itself. He showed that exponentials can rotate, that imaginary numbers were not imaginary at all, but spinning real numbers in disguise. And Euler's formula isn't just a curiosity, it's everywhere. In electrical engineering, it's used to describe alternating currents. In quantum mechanics, it governs how particles behave. In signal processing, it brings your life to music. It links growth and rotation. It shows that complex numbers aren't just weird, they're essential. Euler unified 2 worlds, the static, rigid world of real numbers and the dynamic, swirling world of complex motion. He didn't just give us a formula, he gave us a new language to describe our world. So here we have Euler's formula, and now let's go ahead and substitute pi in for our x. Here we go. Well, sine of pi is going to equal to 0, so that's just going to go away. Cosine of pi is -1, so we have e to the I pi is equal to -1. Let's go ahead and add this to the other side, and that is actually going to give us Euler's identity. Here we go. This is it. The identity, which most mathematicians regard as the most beautiful, is derived from Euler's formula, but we don't know if Euler actually found it. Mathematician Robin Wilson writes, "We've seen how Euler's identity can easily be deduced, but even Euler does not seem to have written it down explicitly. It seems to be unknown who first stated the result." Nonetheless, the identity is fascinating and can most definitely be attributed to Euler. When you see this identity, you're not just seeing math. Something that says the universe is not random. It is written in a language, and that language is beautiful. And it's all thanks to the greatest mathematician of all time.